Hello everyone. So welcome back to my channel. So in today's video we will discuss some more MCQs regarding nuclear physics. Okay. So this is our I think second lecture regarding MCQ practice for nuclear physics. So I have already written the question. It says that a group of alpha particles is emitted from bismuth 212. Their energy is given 6.08 MeV. We need to find the alpha disintegration energies. Okay. So for this you need to know the relation. Disintegration energy. Disintegration energy is given by Q alpha, and the relation of Q alpha, that is the disintegration energy, with the kinetic energy K alpha is A by A minus 4 into K alpha. Okay, this is the kinetic energy. So now for bismuth, A is given 212. So 212 by 212 minus of 4 into 6.08 MeV. Now if you calculate this, you will get 212. This is 212 by 212 minus 4, that is 208 into 6.08. Now you see this 212 by 208, this value will be obviously great 1 point something, right? So the overall answer will be slightly greater than 6.08. So this answer is not slightly greater than, so this one we will cancel out. This answer, this is far away from 6.08 and this is less from 6.08. So the only answer that is right is 6.2 MeV. Okay. So what we need to know? We need to know the formula which is connecting the disintegration energy of the alpha particle with the kinetic energies, and the relation is this: Q alpha is equals to A by A minus 4 into K alpha. Okay, and second thing which you need to know is the calculation part. You have to observe the answers and you have to find the answer. Okay, see if now you may think that I will get calculator, so what's the need of giving importance to this type of calculations and all. This is going to save your time. Okay, and for exams like SAT examination you will get no calculator, so make yourself free uh, being dependent on that calculator part. Okay, now question number 2. This is from radioactivity. Okay, so question number 2, it says that how many half life have if 7/8 of the sample has been disintegrated. Okay, so we know that n is equals to what? N0 e to the power minus lambda t, where N0 is the initial amount present in the sample and n is the amount present after time t. Okay, so now we need to find out the number of half lives. Okay, so here sample disintegrated is given as 7, 8. So sample left is clearly 1 minus 7 by 8, N0. So this is N0 by 8. Okay. So the formula for finding the number of half-life is N by N0 is equals to 1 by 2 whole to the power n. This is the number of half-life. So here N by N0. N, this is my sample left, this is my N. N is N0 by 8 and this is N0, that is equals to half to the power n. So this is now 1 by 8, that is 1 by 2 cube, that is equals to half whole to the power n. That means n is equals to what? 3. So my option A is correct. See what they have said in the question, that how many half-life have, wait, let me recheck the language of the question. How many half-life have if 7/8 of the sample has been disintegrated. Okay, so my initial amount of the sample is N0. Okay, and n is the amount of the sample left after time t. Okay, and this is my radioactivity law, that n is equals to n0 e to the power minus lambda t, exponential decay. Sample disintegrated is what? 7a, right? So sample left is what? Total sample is n0, n0 minus 7 by 8, that is 1 minus 7 by 8, that is n0 by 8 sample. This is my n after time t. Now the formula for finding the number of half-life is n by n0 equals to half to the power n. So n is what? N0 by 8. We are substituting this value and we are getting 1 by 8. So 1 by 8 can be written as 2 cube. So if we just compare, we are getting n is equals to 3. Okay. So next question, the half life of A equals to 50, A is an element, is 12 days. How many days after which 80% of the sample will decay? So for this we need to know that my lambda, that is the disintegration constant, that is equals to T half, that is equals to ln2 by T half. Half life of an element A is given 12 days. So this is given to us. How many days after which 80% of the sample will decay? So 80% of the sample 80% of the sample is decaying. 80% of the sample is decaying. So left amount of the sample is how much? 20%. So n is what? N0, 20%, that is N0 by 5. Okay, so we know our radioactivity law is n is equals to N0 e to the minus lambda t. So we need to find the value of t. Now n by n0, that is equals to e to the power minus lambda t. So lambda t is equals to what? Ln n0 by n. I hope you understood the calculation. Now n0, n is what? N0 5. So we are getting lambda t equals to ln 5. So t is equals to 1 by lambda ln 5. So now we will find here lambda. Ln 2 and t half is given as 12 days. So this is my value of lambda. We are getting this in term of days. Okay, so the answer also they have asked in days, so we don't need to convert it. So t is 1 by lambda ln 5 and lambda was ln 2, 12 days. So 12 into ln 5 by ln 2, this you can calculate using the calculator provided in your exam. So you will get 12 into, you will get some value over here and the final answer you will get is 27.8 days. Check this value and let me know whether you are getting this answer or not. So what is the important thing you need to know? First, this radioactivity law. This you need to know. Each terms you need to know what each term is telling us, the info about it. This you need to know, and this relation between disintegration constant and T half. Okay, that is the half life. Then you can find the T, that is after how many days 80% of the sample is decaying. If 80% of the sample is decaying, so amount of the sample left is how much? 20%. So my N, that is the amount of the sample left after time T, is 20% of the total sample initially present at time T equals to 0. That is N0 by 5. Now this we have substituted here and just calculation we have done. Okay. Now next question. Question number 4. The next question is the atomic ratio between 23892 uranium and 23493 uranium in a mineral sample is found to be 1.8 into 10 to the power 4. The half-life of 23892 uranium is 2.5 into 10 to the power 5 years. We need to find the half-life of 23493 uranium. So, see what info is given here. Here they have given us the half-life of 23892 uranium and the atomic ratio between 23892 uranium and 23493 uranium is given. Okay, that means 238 by 234. This is given as 1.8 into 10 to the power 4, and T half of 238 uranium is given as 2.5 into 10 to the power 5. And what we need to find is the half life of 234 uranium. Okay, so there is a condition for secular equilibrium, and that is what that says that, okay, let me remove this. I hope you understood this, that what info is given and what we need to find. Okay, so the condition for secular equilibrium is n1 lambda 1 is equals to n2 lambda 2 is equals to constant. Okay, so this is the condition for secular equilibrium, so this we will use here. So this can be written as what? N1 lambda 1 is what? ln2 by t half, right? N2 lambda 2 is what? ln2 by t half. Okay, I am considering 238 as 1 and 234 as 2. Okay, so n1 by n2, that is t half of 1, that is 238, and t half of 2, that is 234. We need to find t half of 2, that is t half of 1, which is given as 1.8 into 10 to the power 4, and n2 by n1, which is basically 1.8 into 10 to the power 4 by n1 by n2 is given, so this one will be multiplied with 2.5 into 10 to the power 5 years. So this calculation we will do, and we will get 10 to the 4, 10 to the 5, 10 to the 9 into 1.8 into 2.5. This calculation you can do in your calculator. Also, I think 25 table everyone knows. 25 8 is 400. No, 25 8 is 200. 18 25, 25 8 is 200, and 25 1 is 25, so this we will get is 45, and there is a decimal, so 4.5, so we will get 4.5 into 10 to the power 9 years. So I think option A is correct, 4.5 into 10 to the 9 years. Okay, so basic important thing which you need to know is this relation: n1 lambda 1 is equals to n2 lambda 2, and lambda 1 is ln2 by t half. Okay, and the calculation part, which I'm sure you can do it. Okay, now question number 5, the binding energy of the live nuclei in MeV is given as this. The value of Z we have to find when for the most stable isobar. Now the condition for most stable isobar, is del B by del Z, that is equals to 0. Here the variable parameter is Z. Okay, so now first we will write B is 16A minus 20A to the power 2/3 minus 3 by 4 Z square A to the power minus 1/3 plus 30 N. Now here N is what? A minus Z. So we will write here A minus of Z that square. This basically gives us my A minus 2Z by A. Now we will partially differentiate this with respect to Z. What we will get? Here there is no Z term. Here no Z term. Here there is a Z term. So this one we will get 2Z A to the power minus 1/3 plus 30 by A. Here there is a Z term. So minus sign will come to A minus 2Z. And here again for this 2 you will get here 2, right? Okay, so this is equals to 0. So minus 3 by 4 2Z A to the power minus 1/3 minus 4 into 30 by A minus 2Z. Now this, here there is a minus sign, so this 4 and this 2 is cancelled out, so we are getting 3 by 2 Z A minus 1/3, that is equals to minus 120 by A. Here there is A, minus minus plus, so 120 into 2Z by A. Okay, now Z term we are bringing it together, minus 120. Okay, so if we take Z common, so we are getting here 3 by 2 A to the power minus 1/3 minus 120 into 2 by A, that is equals to minus of 120. Okay, so Z is equals to minus of 120 by 3 by 2 A to the power minus 1/3 minus 120 into 2 by A. So this is 120. I am just balancing this negative sign. This I am writing here. So 120 into 2 by A minus 3 by 2 A to the power minus 1/3. Now 120, this if I am taking A common, so 120 into 2 minus 3 by 2 A to the power 2/3, right? So 120 A by 120 into 2 minus 3 by 2 A to the power 2/3. Okay, now let me see the form of the answer. Okay, so the answer form is not given. Let me see the options. Okay, so the options are in this way. Options are option A by 2, 1 minus A to the power 2/3 by 160 minus 1. Option B, A by 2. Option C, A by 2, 1 minus A to the power 2/3 by 120 minus 1. And option D is A by 2, 1 plus A to the power 4/3 by 64. Okay, so these are the options. So clearly we can see one thing, that A by 2 we have to take it outside, right? Because in all the options A by 2 is present. So now we have to manipulate in this way so that A by 2 comes out. Okay, so this was our final form. So A by 2, if I am taking it common, 120 into 2, this one will balance out, 240 minus 3 A to the power 2/3, again into 2 if I am doing this, and this 2 will come here, right? Yes. So now we are getting A by 2, 120 into 4, that is 480 by 480 minus 3A 2/3. Okay. Now if I divide this by 480, what we will get? 1 by 1 minus 3 by 480 A to the power 2/3. So A by 2, 1 by 1 minus 1 by 160 A to the power 2/3. Okay, so this can be written as A by 2, 1 minus A to the power 2/3, 160 whole to the power minus of 1, right? So let's see which answer is matching this. So option A is correct. Okay, so the concept here is that most stable isobar del V del Z is equals to 0, and then basically the calculation part where you need to be slow and steady. Okay, so we will stop here today. Keep studying. Thank you so much. If you like this video, please like and subscribe and share among your friends. Thank you.